Hello, good evening, friends. Today we are going to learn about electrostatics. It is the first and the foremost chapter in our syllabus. And whenever we think about this chapter, electrostatics, what does the first thing occur in our mind? Electrostatic. Electricity will was the study of flowing charges. Now, electrostatic must be the study of static charges. Yes, you are right. So, we are going to learn about charges in this chapter. How charges apply force on each other, does they attract each other, does they repel each other, does they have any consequence on the surrounding. Okay, so first thing we know about charges that charge is denoted by a capital letter Q. Its SI unit is coulombs. SI unit is coulombs. Coulomb. Okay, now charges can be classified into two types. That is a positive charge and a negative charge. So, what will happen if I take a positive and a negative charge close enough to each other so that they can exert the force? What will be the nature of that force? Yes, two unlike charges. If taken close to each other, then they will attract each other. Attract each other. Okay, but instead of taking two unlike charges, if we take two like charges, then the force that they will exert on each other will be equal and opposite in nature so that they can repel each other. Okay, so now we get the first property of charges, that is like charges repel and unlike charges attracts. Yes, it is the law of the nature. Like charges repel each other, unlike charges attracts each other. Okay, always remember these two things. Like charges repel, unlike charges attracts. The next thing that we are going to learn about this charge, just think about the question: what is the smallest charge that can be transferred from a body to another? Yes, we have heard about electrons. Okay, what is the charge on one electron? It must be 1.602 into 10 raised to power minus 19 coulombs. The coulomb spelling is spelled as coulombs, but it is written as coulombs. Okay, remember this also. It is denoted by capital letter C. It is 1.602 into 10 raised to power minus 19 coulombs. What is the mass of an electron? It is 9.1 into 10 raised to power minus 31 kg. Correct. Now, if we want to give one electron to another body, then the body will lose 9.1 into 10 raised to power minus 31 kg. That is negligible. It can be neglected. Okay, it can be neglected. But this charge 1.602 into 10 raised to minus 19 is a little bit greater than this mass. So we can consider this charge. But can we consider in daily life? No, because in daily life we occur the charges that are very great in number. That is, we just use one microcoulomb, millicoulomb. Okay, that we use in our daily life. So let us see about the property that is called as quantization of charge. Let us set the charge into quantity. It comes with a formula. The formula is Q is equal to Ne, where Q stands for the charge, N stands for the number of electrons, and E stands for the charge on that electron. That is 1.602 into 10 raised to power minus 19 coulombs. Okay, Q is equal to Ne. So from this formula, let us take out the number of electrons that are needed to give 1 coulomb of charge to a body. What is my question? I will repeat it. What will be the minimum number of electrons that will be needed to transfer 1 coulomb of charge from a body to another? Okay, so we have charge of 1 coulomb, so I will put 1 here. Okay, 1 coulombs is equal to N is the question, and E we have 1.602 into 10 raised to power minus 19. Okay, so now if you solve this equation, you will get n is equal to 1 by 1.602 into 10 raised to power minus 19 coulombs, and this will be your homework. Okay, just take out this n. What is this? What will this n give? This n will give us the number of electrons that will constitute of 1 coulomb of charge. Okay, so that's all for this today's lecture. Have fun. Bye. See you. Have a nice day.